Good morning, my dear kids. I'm Sridhar, your physics teacher. In the chapter Basic Maths, today we are going to learn a very interesting topic called as the calculus. In that, there are two topics are there, the differentiation and an integration. So the first part is what we are going to deal, that is called as the differentiation. I'm saying interesting. What all we have today, modern science, what you see today, modern science, all this research, everything started from almost, you can say, from this calculus only. Without calculus, we cannot analyze anything in the engineering or in the medical field. So what all we have, the modern science and technology, everything stands on the calculus. It's a very, very versatile tool which will help us a lot. I'm saying that one. So the whole modern science and technology has begun from this calculus only. It's a very important tool, which we have to learn the meaning of that, the essence of it, significance of it. Numerical solving, anyway, you're going to learn in mathematics. I'm not bothered about the numerical solving ability, but here I'm going to stress what do you mean by that. We will write equation, we'll write one formula. What is the meaning of it? How to use it? In what all ways I can use it? This is the most fundamental. The question is what you have to ask yourself whenever you learn any calculus, any equation. Okay, what is use of it? Okay, you are able to solve problem, but what is use of it? Where it is used and how I can use in applications. If you can learn this, you'll become one of the best doctor, one of the best engineer. I'll bet you. Sir, why doctor need calculus? I think you go to if you just become ordinary doctor, okay, just see patient, write some slip and send him. Okay, it doesn't matter calculus. But if you want to really become a research doctor, you need all this. The cell working is better understood by mathematics than by any other thing, the mechanism. So please do, all of you, whether you are a advanced stream, JEE mainstream or the medical stream, any mathematics comes, not just mere question answers or formulas or some procedure. What is the meaning of it? What is the use of it? And how it is used in various applications? Is it anywhere related to my day-to-day life where I can use it? Like you have seen arithmetic progression. Is it really something just a formula? No. You have yesterday seen geometric progression. So learn maths in such a way that it is more interesting and more applicable, not just mere question answer time. I'm against the maths of that kind, which is just question answer, some procedure, okay, and solve the answer. And finally, what you learn, nothing. Please say, rectify it. I'm not saying it's wrong. It's only primary, it's only a secondary stage. You have to come for the primary stage of maths, the application part. Okay, let me not waste your valuable time. Let me start the calculus. I think I should not be visible because they are such a great persons. I'm no way eligible to be with them. Okay, now these are the two persons. What happened? The founders of calculus, what you can say, the Newton, what happened? The Sir Isaac Newton, better will call Sir Isaac Newton, to express his Newton laws of motion. He verily, and to express the propagation of sound, there what happened? He expressed the phenomena of nature, that infinitesimal calculus is what he has introduced. Further, what happened? The Sir Gottfried Leibniz, he has carried further it, all the different methods, the different conventions, the different formulas, he has carried forward it. Okay, fine. So these are so if you get any time, please do read something about this, such a great people, where we are, say we can, what all we have modern science, it's because of them. So we are very, really, very thankful for such a great persons who has given such a very good mathematical tools, where the human mankind today is what we are able to utilize the science and technology to in our day-to-day life because of them. Okay, let's calculate. So if you can, okay, let's go for our discussion. If you can remember, we had a discussion about That's come for you. Yeah. So if you can remember, we had a discussion about the slope. Okay, in which class? At the very first class, I think the straight lines in the graph analysis, I started with a slope, if you can remember. The idea of the slope is what we introduced there. Now, here also now we will focus once again on the concept of slope. What is the use of that? And later for different curves, we'll go for how to get the slope. So now if you look at the straight line, there's like a straight line passing through origin. Then I'll ask you to find out the slope. So what you're going to do is you're going to choose 2 points on a curve, A and B. Then corresponding to that from B, you're going to drop one vertical and horizontal line, or so draw perpendicular to X and Y axis. Then similarly at point A, you drop a perpendicular to X and Y axis. This difference, horizontal separation, is what delta X. The vertical separation between points B and D will become delta Y. So then tan theta you define opposite by adjacent. This tan theta is what slope. I think we are very strong enough to find out the slope for a straight line. Already we had discussed many numericals. Similarly, look at this curve. The slope, in fact, will be negative, no? Here. So again, the same method. I'll choose points A and B. Corresponding to that, I'll draw horizontal and vertical lines. So delta Y, delta X. So tan alpha, delta Y by delta X. I'll get a slope. So the slope will be negative. Or you measure with, sir, like I don't know this. Okay, you do one thing, take protractor. Measure angle made by this line. Okay, there's a experimental curve is what we'll call. Experimental curve, it is called as. Then how we define the slope, delta Y by delta X. So what we do is I'll take the protractor, I'll measure the theta, tan theta of that is what slope. There's a geometry, this is from geometry method. Then the analytical method is what I'm showing, find out delta Y by delta X. This slope is positive. Slope is positive. Or the steepness, the measure of steepness of this line. So these are experimental curve, and the slope of this straight line is negative. So as the X increases, Y decreases. X increases, Y increases. Okay, this idea. So now we are very good in calculating the slope. Okay, let's ask ourselves a primary question. Okay, let's have a curve. Y equal to X square. This is the equation. For this, let's plot a graph. Then we'll ask ourselves a few very fundamental questions. Then we'll say that can we answer it or not? Y equal to X square. X equal to, let me choose the values. I have to plot a graph, no? For that X equal 0, 1, 2, 3, 4, 5, 6. Corresponding values of Y are shown in this Y column. Look at here now. And then let me ask myself, let me find out the slope of a curve at point P. This is a curve. Okay, where is it? It's a curve now. Now from straight line, we have entered to this is a curve, no? For this curve, at X equal to 4, you have to find out the slope. So then corresponding to X equal to 4 here. So that the point P, here I'll draw a tangent. Able to notice the red color line is a tangent. This red color line is a tangent. I'll draw a tangent. That's all, no? Because what is the slope? How we define tan theta, and what is theta? Angle made by the tangent drawn at point P. We'll get a slope. And how you measure theta? By protractor. Everyone knows protractor by this time. Don't know protractor? Okay, just open geometry box, something like a semicircular disc, plastic one, and on it some lines will be there. These are the lines. 0 degrees, This is 90, 180 degrees. Fine. So this is the slope of that particular thing. Huh? There's a protractor like this. You keep it, you measure theta, find over slope over. Sir, I want slope at 2. What you should do? Again, draw a tangent corresponding to x equal to 2. So it will like a draw a vertical line. It x equal to, you want to draw a vertical line. It will intersect the curve at this particular point. There you draw a tangent. Then find out the theta. Tan theta will be the slope. There won't be any issues with geometry method, what we know it. What is the slope of at different points? It'll be different. The slope of this curve is different at different points. Slope of straight line is same at all points. But for a curve, the angle made by tangent with horizontal will be different at different points. So it is what we are, I mean to say is, if you take this as a, so you draw a tangent at various points. So how to draw a tangent? So here you draw a line. Here you draw a line. So look at this. So what's happening to point P1? So this is y and x. So definitely theta 2 greater than theta 1. So therefore what we can write? Tan theta 2 greater than tan theta 1, or slope of curve at 2 greater than slope of curve at 1. I think very simple. Anybody can do this. So for a curve, slope, will it be a constant? Need not. It may be increasing or decreasing. So here what we have here a curve where slope is increasing. So can you show for decreasing also, so that we will be very thankful for you. I think you should thank the above persons whom has shown, because of them is what all this modern science what we have. I'm just mere a teacher sharing some ideas, what I know. And the slope of decreasing one, can you show it? Okay, slope of decreasing curve. Point P1, these are point P2. What is the angle made by tangent? You will see theta 1. Definitely theta 2 less than theta 1, tan theta 2 less than tan theta 1. Slope of curve at 2 less than slope of curve at 2, it is in fact less than 1. So slope here, what we say, slope increasing. What about your slope is decreasing. Okay, agreed. This one. Okay, this what? How to calculate slope? So shall we say that take protractor and measure theta, tan theta. Is there any other method? Okay, we'll try. We'll try that one. So I'll start with this one. The same curve, what we had, same y equal to x square. The same, that curve only, I just show it. So I want the slope at x equal to 4. Okay, sir, here also I'll draw a tangent. Let me draw a very, very, very interesting thing. Everyone should, it is something very important for physics. Maths maybe is a slope, but in physics, this is something very, 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 very important. I drew a tangent corresponding to point P. At x equal to 4, we have to find out. So find slope. What is our primary question? Find slope of curve at x equal to 4. Here, look at the tangent. Okay, son, once we get the tangent, so shall we go for that points? What are the points? Like a delta y, delta x is what we are supposed to calculate. So I'll bring the, let's see that how we manage things here. Now, delta x, there's no problem. Am I right? What is delta x? X1, this is x2. So I think I'll bring this tabular column. This tabular column is something. I'm explaining one of the best ideas of the differentiation. This is something very, very important. I'm making things clear. Try to see this. So this is something very, very, very essential part of the total calculus is what I'm trying to stress. So what is x1? X1 equal to, let me highlight with this. This is x1. This is something x2, no? So therefore x1 corresponds for 3 and x2 corresponds for 5. So let me write it. This is x1, this is x2. What is the corresponding value of y? We know. If x equal to 3, y should be 9, no? The corresponding value of y is 9. The corresponding value of y is in fact 9. Okay, there's no problem. I'll just indicate here. Then for corresponding value of 5, x equal to 5, this should be 25. But actually delta y you're calculating. So what is the problem? This you'll get it some value which is we don't know. Sir, what do you mean by don't know? What do you mean by don't know? When you measure this, sir, I'll do one thing. I'll take a scale. Okay, definitely it will not be 9, no. It will not be a 9. Okay, let it be no problem, sir. I'll measure. So corresponding to x1, what is the value of y? The y should be how much? Should be 9, no? But how much you are tabulating? You're putting something other than 9, which will not obeyed by this equation. So then sir, can you say this slope as delta y by delta x? The answer is no. What you calculated slope tan theta here, tan theta is what? The slope is not equal delta y by delta x. Sir, what is this? Because first of all, we don't know y1 and y2. Because for x1, what should be the value of y? Should be 9, but how much you are getting? Something y1, which is not there in, which is not at all experimental point, no? For x1, for x equal to 3, y should be 9, but how much you're getting? You're getting other than that, which is not an experimental point. So something went wrong here. Means you can't just say that here slope is delta y by delta x. Sir, what is this? That's what I'm saying. For a straight line, you can write it as tan theta, slope equal tan theta. But sir, I'll do one thing, sir. I will calculate by calculator. Sorry, I'll take the protractor, I'll calculate theta. Okay, no problem. Tan theta I'll get, but the tan theta is not delta y by delta x. This is something I must write it. Slope equal to tan theta, no problem. But tan theta, but slope is not equal to here delta y by delta, because delta y itself is not defined here. Delta y itself is not defined. Then how to calculate slope? So is it only protractor is what available for us? No, we do have a method called like a calculus here. So what went wrong here? What went wrong? For a curve, the slope is not delta y by delta x. Because at different points, the slope is different. At different points, the slope is at different values of x, the slope is different. So when slope is equal to delta y by delta x for straight line, for a curve, it will be different at different points. So then what I should do? Here we are going to introduce the idea of the calculus. Here I'm going to introduce the calculus. So what we do is like, It is like this. So no. Shall I make delta x very, very small? Earlier, the delta x is this much of big. So I'll make it very small. How much of small? Tends to 0 and equal to dx. When delta x tends to 0, then the small change in infinitesimal change in x, we'll call that as dx. Then corresponding change in y, let it be dy. I think I'll put it one more curve. Drawing curve little bit. Yeah. So at a point corresponding to this, we have to calculate the. So shall we do one thing? I will take the delta x. No, but what is our question? We wanted like a delta x will not help us anything, no? And this is the delta y. I think I'll adjust it. Yeah. Okay, now I think it's troubling me. Some graphics. Yeah, I can carry on. Okay, now this was the delta x. I'll further extend this. So what we did is like we thought like, okay, this is the delta x, and here is what? So this is what the delta x value, no? And this is what the delta y. So therefore, we have to draw a tangent at one specific point. So therefore, what I do is like I'll just suggest a simple idea. What is the idea? The idea is I think it's troubling me a lot. I'll explain in simple diagram why to make it complicated, because this is something very fundamental. Now, this is delta x. I think I can show it here. Now what will happen? I'll make delta x so small that it will become dx. Earlier this is delta x. Now this delta x, what I'll do? I'll make it so small. The delta x becomes so small that delta x tends to 0 and it'll become what we call dx here. Similarly, on the y-axis also the same thing. No, this is delta y. I'll make it so small that delta y, so the change in delta y is so small that delta y tends to 0, it will become dy. Now the ratio of this dy by dx in fact will become slope. Let me move this. No, the ratio of this dy by dx. So what is delta x? Delta x now has become, so that delta x is here. I have patience. Let me, I wanted to put very neat explanation. Yeah, we have everything here now. what is delta y, sir? What is delta x and what is dx? Please better explain clearly. And that's what I'm trying to do. This is delta y. This is delta x. And what is dx? This is dx. This is dy. Here is what we get some small infinitesimal triangle. I'm just shading it. Okay, this triangle, I'm just expand it. So when I expand it, when you magnify it, you do end up like this here. So what is this quantity? This is theta. This is dy. This is dx. Now tan theta, you can write dy by dx. But tan theta is not equal to delta y by delta x. This is something very, very important. So now, sir, what is tan theta? There's no problem with this. So first of all, can you say what is dy dx? I think you can see delta x tends to 0. Then delta x, what happened, will become dx. Delta x only will become dx here. The small infinitesimal change in x. Delta x means what you write? Change in x. Dx, what you write? Infinitesimal change in x. We should call like this. Delta x means change. Infinitesimal change. Infinitesimal means very, very small. So when delta x will become dx here, so when delta x almost tends to 0, then the delta x will become dx here. I think that's what I did. No, the delta x earlier was certain value. The change is so small that dx, sir, what is, can you say anything about dx? Dx may be 0.0000000, but not equal 0, but it'll be tends to 0. Fine. So the ratio of that, then correspondingly a small infinite change in dy. The ratio of that two is what now tan theta, which is nothing but equal to slope. So what is dy by dx? Slope of tangent drawn in yx graph. How you define dy by dx? Tan theta, which is nothing but slope. So how you define dy by dx? Slope of tangent drawn in, slope of tangent, slope of curve, or slope of tangent drawn in, or say in yx graph, or slope of tangent drawn, slope of tangent of the curve drawn in yx graph. Anything you can put it. So where is the tangent? That was earlier method. Geometrical method is what we do. We'll draw a tangent corresponding to point P. I'll find out tan theta. I'll get the slope. Another calculus method, what say? Just find out the value of dy by dx, the ratio of dy by dx. Can we find out dy by dx? No. Not on paper. We should bring a new mathematical tool called as a differentiation to get the value of dy by dx for a curve y equal to x square. Are you getting? Not on paper. So we should bring a mathematical tool. We are going to introduce a mathematical tool called as a differentiation. From this equation, I am going to bring the value of dy by dx. Then I can calculate the slope of this curve at any point. Are you able to notice here that delta x tends to 0 will become dx. The ratio of dy by dx will become now slope. That's what I'm showing it. This triangle is what is here. Very small infinitesimal triangle. So what is this? This is called as infinitesimal in that triangle. The ratio of dy by dx will become a slope. Okay, fine. This is the primary part of this one, or nothing but what will rate of change of y with respect to x. What is another way of defining this one? We can also call it as rate of change of y with respect to x, or ratio of infinitesimal change in y to infinitesimal change in x. This is graphical method. This is using differentiation. What we can calculate slope. How to calculate slope of a curve at any point? Geometry method. This by a tool, mathematical tool called as differentiation. So let me highlight here. These are the two. So there's a mathematical tool will write it. And what is this? Using geometrical instruments. And what was the question now? They've asked how to calculate slope. You have two methods in front of you. Okay, this is a primary idea of this one. Okay, I think we have to explore a lot. This is just only basic tip of iceberg is what I'm just discussing it. We have to really explore a lot of content. Okay, all of you getting some idea. So no, one primary comment is what I'll pass it. Delta y already is not equal to, so this delta y cannot be determined. I think somebody were asking doubt. So this delta y cannot be determined graphically. That's why we have introduced that tool called as a differentiation. Okay, let's get into some let it be. Okay, we'll carry on now. Okay, so the same thing. Let me bring that differentiation method. So y is equal to x square is what our discussion started with this one. No? Y equal to x to power of 2. Let small change in x be delta x. Then the corresponding change in y be delta y. So how you have to interpret? Let small change in x be delta x. Corresponding change in y be delta y. Then this y I'll take outside x square delta x by x square. Okay, this everyone know these two will cancel out. Because y equal to x square is what given, no? So then this will become 1 plus delta y by y, 1 plus or minus delta x by x whole square. So this will be 1 plus or minus delta y by y, 1 square, delta x by x whole square, plus or minus 2 into 1 into delta x by x. This one also get cancels. So something I did. So what is let limit delta x tends to 0? What does it mean? Then the delta x, what happened? I had to write it as dx. If delta x is very small, then delta x square will become negligible or tends to 0. So then the expressions will become plus or minus delta y by y, limit delta x tends to 0, limit delta x tends to 0, plus or minus 2 delta x by x. So therefore this will become plus or minus limit this will be delta x tends to 0, delta x by x. Now this will become delta y by delta x. Let me write it in. This will become plus 2 plus or minus 2 1 by x. Y by x will write it. Here also if you want to write limit, okay, it doesn't need it. Sir, what happened? This limit, you mean to say it tends to 0 here, or else very small, no? Okay, just we'll keep it here. Okay, this will be more systematic for you. So now, this, if I write it, it will be dy by dx. If delta x tends to 0, delta x is very small, then it will become dx. The corresponding y also, delta y will become dy. So this will become dy by dx, which is equal to plus or minus y by x. So what is y? We assumed x square. So finally, I landed up with the equation which is equal to how much? Plus or minus 2x. Or just you are going to write dy by dx is equal to 2x. What you have found out? You have just determined the value of dy by dx. This is called like a differentiation method. Later on, actually, you are supposed to learn continuity, limit. So many laws are there. I'm just sidelining. I'm just giving only the essence of the differentiation. So don't scold me once when you learn the calculus again. Don't scold me, sir, how you are taught all these things. So what is the value of for y equal to x square? What is the value of dy by dx? Mean this one. You should not cancel this d and d. This is called like a derivative. Derivative of y relative to derivative of x. That should be equal to 2x. What was the question? You have to calculate the find slope of the curve at x equal to 4. I think this is the curve. We were supposed to calculate the slope of curve at x equal to certain value, no? Hope I think if I remember, it was find the slope of curve at x equal to 4. We'll ask ourselves question. Find once again, find the slope of curve at x equal to 4. So corresponding to x equal to 4, I will locate a point. Then what I'll do? There I will draw a tangent. What is this red color line? It's a tangent. Then I'll measure theta. Tan theta is what? Nothing but slope. I think this we know by geometry method. What is the slope? Already we have discussed. Now, is there any other alternative method? Just put x equal to 4, you'll get the same value. This is equal to how much? 2x. Put x equal to 4. How much you'll get? Slope 2 into 2. Put x equal to 4, no, sorry, 8. So you do one thing, sir. Are you sure? You do measure theta, tan theta, you'll get the same value. This is the best method, no? Somehow you have to learn how to differentiate a function. So how you interpret this? Rate of change of y relative to x, or slope of tangent drawn in yx graph. Slope of tangent drawn in yx graph. What is the dy by dx? You can also write it is equal to. So this is also equal to slope. You can write it, no? So what is dy by dx? Slope of tangent drawn in yx graph, which will be easier. If I give equation, I'll ask you to find out slope. Somehow, if you can differentiate this, so put x equal to 4, you get slope. Or else, you should plot that graph, take scale, draw a tangent corresponding to x equal to 4, then measure the angle theta by protractor. Tan theta of that, you'll get the slope. The two methods are there. One, using geometrical instrument. Other, by a mathematical tool called as differentiation. Sir, I want slope at x equal to 3. Let's substitute x equal to 3. You'll get 6. Like that, at any point you can calculate slope. Just you substitute the value of x here. Where you want, okay, there you can put it here. And look at the, as x increases, slope increases. So therefore, I think I'm very sure already we verified. So the slope is increasing. As x increases, the slope increases. Means like a, you mean to say like a slope versus x. Let me compare both the curves. Okay, this was the curve for y equal to x square. Can we plot the slope versus x? How it will be? I think it should be a straight line passing through origin. What is this? This is the curve for dy by dx and as a function of x. Dy by dx equal 2x. There's a slope. Slope, how it varies with x? Equal to this particular thing. Put x equal to 1, 2, 3, 4, and the slope will also gradually will increase. This is the experimental curve. There's a variation of slope with x. Now you can ask questions, sir. What is use of this? Okay, we have found out slope. Okay, that one. Like a